Good. Hello. Hello, everyone. This is Lab 5, and today we will be doing practicing our methods. Let's read our first question and hop right on into it. Question 1, times 10 method. Write a method named times 10. The method should accept a double argument and return a double value. That is 10 times the value of the argument. Demonstrate the method by calling it from the main method and passing any double value to it. Print the returned value on screen. All right, let's start number 1. Give me just a second. Let me share my screen. I gotta make myself small and share my screen. Give me just 1 second. Working on the screen sharing. Share screen. Here it is. And I also have to be in there. Can you see me? You should. Ding. Okay, let's share. You should be able to see me. I'm gonna move this over yonder so you can see everything. Should be able to see me and hear me without too many issues. Okay, let's get into it. So we're supposed to be making a times 10 method. So let's make our times 10 method. The method must be outside of the main, but still within the class, as Dr. Darwish explained to us in class on Tuesday. I believe it was Tuesday or Thursday last week, this past week. First, let's create our method real quick so we don't have to do anything too crazy. I'll explain all the code later on at the end. So I'm going to focus on typing it out. So I don't have to type this out all the way. I'm going to just copy this here, as you can see, and edit it to how I need it. Since the instructions call for a double, so I'm going to make it a double. Double. And it's supposed to be called times 10. All right. Why is it angry? I was going to do that later anyway. Okay, now we have our double, and we're going to need to add a few things later on. But for now, let's get everything together. Filtered all type of wrong. Gotta concatenate. Yes. All right. Let's go through and explain the lines of the code. First, first, let's start here. We're going to start inside of the main method. In the main method, we call the times 10 method with the argument 5.5 and stored result and stored the resulted value in the variable results over here. Then we did this print statement to print out the result of basically the calculation. So let's move down here to our times 10 method. So in this method, we use this method to multiply and give the double value by 10. This is basically multiplying value by 10, the input being, my brain just got jumbled. Okay, let's start that sentence over. Here on this line here, we're multiplying the input value by 10 and return the result, basically. This right here. Let's run it. And the result is 55.0, and it's 0.0 because it is a double. Moving on to the next one. Let me read what it is. Let's bring it up. It's a bit long-winded. Question 2, falling distance method. When an object is falling because of gravity, the following formula can be used to determine the distance the object falls in a specific time period. D, as in dog, equals 1/2 GT2. The variables in the formula are as follows. D is distance in meters. G is 9.8 constant. So it's a constant. It doesn't change. Okay, we got that. And T is the amount of time in seconds that the object has been falling. Write a method named falling distance that accepts an object's falling time in seconds as an argument. And the method should return the distance in meters that the object has fallen during that time interval. Determine the method by calling it in a loop located in the main method that passes the value 1 the value 1 through 10 as an argument and display the return value on screen. That was a mouthful. Okay, let's get into it. Let's get into it. All right. First, let's make our method. Excuse me. Basically doing like a little skeleton code. First, let's make our little method so that I'm not confused, you're not confused, we're on the same page. Okay, you can hear me, right? Let me make sure. Like, you can hear me. All right. Second, I thought you couldn't. All right, let's get into our. Excuse me. Ooh, excuse me. Let's get into our method. It's not going to be a void. It's going to be something else. I'm going to make this a double because we have a decimal point in here. So, okay. D-O-U. Yeah, I can spell. All right. Falling distance. Ooh, excuse me. I'm gonna leave that alone. All right, let's start up in our main method. I'll explain everything after. Please don't worry. Let's start with our loop. Allergies. Oof, that could hurt. Don't like that. Ugh, ugh. I'll explain why I use final. Final is so that the Final is so the value does not change at all. What am I confusing for? The dyslexia is getting out of hand today. Come on now. Confusing a nine with a G? Crazy. Back to up here. So I'm just copy this so I don't have to. Okay. Let's go over what this is about. Let's go over each line. Well, not each line, but like let's go over it. Okay. First, let's start at the top of the main method. First, we're gonna do our loop. We're gonna loop through the time values from 1 to 10. That's basically what this is doing here. And then we're going to go down here and call the falling distance method with the t to store the returned value in distance here. Then let's hop down to the little math portion down here in the falling distance method. First, we're going to make gravity not change. It's an unchanging value. That is why I put final. So in this method, we're calculating the falling distance of the object given the time in seconds. And since gravity is consistent, we put final. And since it has a decimal point, put double. And then we're going to do our return value. with this equation, 0.5 times time again. This is the correct formula for the falling distance as given to us in the instructions. Then we're going to print the time in the corresponding distance fallen. Let's run the code so I can see what I'm talking about. Okay, so the time here, so it says seconds, distance fallen, 0.5 meters. 2 seconds, 2.0 meters, and you get it, so on and so forth, all the way down to 9. Maybe I should 11. Oops. Okay, there we go. Now we have 10. I did the math wrong up there. It's supposed to be from 1 to 10. It's from 1 to 10 now. Ta-da! It has 1 through 10 seconds. Now, all right. Moving on to the next thing. Let's read it. It is also a mouthful. Where? Here it is. All right. Moving on, question 3. Centigrade to Fahrenheit method. To the formula for converting temperature from centigrade to Fahrenheit is F equals 9 divided by 5 times C plus 32, where F is Fahrenheit temperature and C is centigrade temperature. Write a method named Fahrenheit that accepts a centigrade temperature as the argument. The method should return the temperature converted to Fahrenheit. Demonstrate the method by calling it in a loop located in the main. Display the centigrade temperature 0 through 20 and their Fahrenheit equivalents on screen. All right, let's do that. I'll explain after. First, let's start with our method as required. It is not a void method. I'm putting int because we're working with integers and not doubles. There's no decimal points in this at all. Okay, Fahrenheit, F-A-R-H-R-E, in right. ID, put our return so it can stop screaming at me. All right. And I'm gonna just put I'll just put the skeleton code here so there is no confusion. Ooh, that was, all right. He can scream at me all he wants. I'm gonna get back to that. Okay. less than or equal to 20. Increment, it goes up by 1. All right. All right. Let me explain. Let me explain. All right. Let me explain. Let's start in the main method with our explanation. In this main method, this loop here, this loop loops through centigrade temperatures from 0 to 20. Then, in this, then we call the Fahrenheit method to convert centigrade to Fahrenheit. Then here we print out centigrade and Fahrenheit equivalents. And here We're converting centigrade to Fahrenheit using the formula F equals 9 divided by 5 times C plus 32. Voila. 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 Okay, here it is. Let me read it out for you. So it's saying centigrade 0. Centigrade 0 is equivalent to 32 degrees Fahrenheit. Centigrade 1 is equivalent to 33 degrees Fahrenheit, so on and so forth, all the way down to 20. Down here, I used this here the to space out centigrade and Fahrenheit instead of just putting like a space in between each one. It was easier just to put a \, T just to make a tab space in between them. Moving on to our last part of this. This one's not as much of a mouthful, but it there. Okay. Question 4, distance traveled method. The distance a vehicle travels can be calculated as follows. Distance equals speed times time traveled. Write a method named distance that accepts a vehicle's speed and time as an argument and returns the distance the vehicle has traveled. Determine the method by calling from the main method and passing two required arguments. Display the returned value on screen. All right. Let us begin by creating our method. Regular integers. So I'm making it int. I'm gonna put int instead of int because there's no decimal points here. Makes sense. And it was supposed to be called distance, right? Distance. Yeah, yeah, distance. DIS. I'll explain everything after. Distance, yeah. All right. My return statement. I'm just copy it from here. I'm not writing that again. Turn. All right. We got that all together. Yeah. All right. Let's start up here at Alphine. Let's say the vehicle is going 60 miles per hour. INT is 60. Let's say it's going 60. SPED. It goes fast. 60. It's going 60. And let's say it traveled 2 hours. Equals it traveled 2 hours. Let's call it up here. Where is it at? All right, we're almost done with this. I'm gonna make a space right here so it's not all jumbled. Copy this and put it over here. Traveled blank in kilometers. In kilometers. Yep. All right, let us explain. All right, let's start from the top. First, we're declaring and initializing the speed of the car to kilometers per hour. And then we're declaring and initializing the time the vehicle traveled per in 2 hours. Okay, now we're calling here, here, we're calling the distance method with speed and time as an argument and stored the results. Down here, we are in this method, we are calculating the distance traveled by the car. The formula, basically, this is in this return statement is the formula distance equals speed multiplied by time. All right. Whoa, didn't mean to do that. I meant to save it. Let's run it. It says the car has traveled 120 kilometers. All right. Thank you for watching. Thanks for watching. Hope you have a great day. One more thing to add, I put kilometers because almost everywhere else around the world, they use kilometers in Celsius. But in America, use a different thing to measure. All right. I know you would probably have a question.